The Sporland division of Parker Hannifin proudly sponsors the Advanced Refrigeration Podcast. There are a lot of questions surrounding the transition to A2L refrigerants and a lot of talking heads disseminating nebulous answers. But when your technician is face-to-face with the first A2L transition project, where do you turn for real-world answers about this specific job? Parker Sporland's Virtual Engineer is an innovative online design tool to size and select the correct components for climate control and refrigeration applications. Get your A2L system flow and component selection answers in 3 simple steps. Enter your application details, size, and select products, then download your project files. It's that easy. Try it at absolutely no cost. Visit sporlin.com and navigate to the Resource Center. Parker Sporland, leading the charge.
Did you get your stuff from the meat market?
No.
You did. Don't lie.
No, actually, I didn't.
Interesting.
I work from home today. I was doing quotes all day. I was staring at this computer, wanting to blow my brains out. I don't know how office people do it. It's absolutely horrendous.
You're horrendous. Good afternoon, everybody. Welcome to Advanced Refrigeration Podcast. You hear the host, Brett Wetzel and Kevin Compass. So what did you do this week?
Pretty slow week for us right now. What did I do this week? Did some EMS stuff.
What kind of EMS stuff?
Some Danfoss stuff, changing out some of that, and then some prep work, trying to line up a bunch more work, and then I spent the rest of the time doing quotes and surveys for sites. So been a super boring week, but next week I'm going to Florida to change an MT computer.
Oh,
and
really?
It's better than the last 2 that I've done.
Why? What happens when what could potentially happen other than having to redo the whole program?
Trying to find said computer, meaning it shipped with a bunch of boxes from the AC manufacturer, so God only knows where it is on site. Yeah, so there's that, and then there's always these unknowns when you're putting a brand new computer in and you've never been to the store before, and yeah, then you inherit everybody's common problems.
And I was going to say star, but you're supposed to have stars. You're allowed to have stars.
Yeah, so that's my next week.
Where else are you going?
I don't know. I want to say Texas, but that would be, I want to go fix Greg's VFD. It would just make you so happy.
Oh my God, it would make me the happiest person alive. I can't wait. Just like I said to you before, though, you better fix it quick. If he gets here, he's gonna struggle with it because I only worked on it a little bit, but I struggle. He's gonna struggle too. So I really can't wait for that conversation.
All right, so what are we talking about this week? Since it's Friday and I'm hungry.
Not my fault. So anyway, I was at NASRC this week, jerk, and my computer literally died. So that's why we didn't record, ass. But yes, so this week I guess we're going to do digital compressors. Yeah, we'll do digital compressors. So
let's do it.
All right. You want to start explaining so I can do what I need to do real quick?
What do you want to start with?
We're just explaining, how a digital scroll essentially works.
So a digital scroll is just a scroll.
Mm-hmm.
It is a scroll.
You're such an ass. Knew you were going to do this. It's just a scroll. Everyone should know how to scroll works.
It's a scroll, okay? So it has 2 plates that oscillate together, back and forth, in a semicircular motion. Okay, that makes the compression. So a digital scroll, what they're able to do is they're able to separate the scroll plates away from each other. When they separate the scroll plates away from each other, they don't compress. so you don't get that compression action. So a digital scroll, what it essentially does is it modulates a solenoid to force hot gas into this compressor, and it separates the scroll plates away. And what that allows it to do is it allows it to unload. Now it can only run separated for so long. So it has a pulse period.
Let me show what the scroll looks like, because now I actually have it where I need it to be. So you have two types, or you can have two different versions of this, by the way. Share screen. Share. Stop belittling Greg. Jesus.
Oh, I should be door.
Anyway, you guys are awful. Just absolutely awful. So anyways, you have two different scrolls, two different digital unloading scrolls. One, you'll actually have an external solenoid, and one, you will actually have a solenoid that still does the same thing. It does it internally. And if you look at like this compressor right there, this scroll basically has two heads on it, right? Two pecker heads on there. You got one there, one for the voltage, one for the solenoid cover. So you'll have another set of wires over there that's going to go to the solenoid. The other set of wires is going to go to three-phase, and potentially a scroll that big, you're going to have a motor protector. They still both do the same thing, like Kevin had said. And what they're actually essentially doing is separating the scroll sets apart. So if you look at this guy right here, basically at one point, why is it not doing it now? That's stupid. It separates about 1 millimeter apart from each other. And what it'll do is not make that compressor load. And what they're doing is, like Kevin started to say, you can finish explaining if you really want.
So it separates the scroll plates away by forcing hot gas on the top side and pushes them away. And it does it by cycling that solenoid rapidly. So like it's right there. So full capacity, 4 seconds on, zero capacity, 16 seconds. It goes on and off. So it's a 20-second duty cycle time. And then it takes and chops up at 20 seconds. So if it's a 10% capacity, maybe 4 seconds loaded, 16 seconds unloaded. Or if it's 100%, it's going to be 100% unloaded. Or I'm sorry, it used to be calling 100% unloaded. So it should be calling for full capacity.
The scrolls can only go down to 10%. 10%
Correct.
is the utmost lowest they can do.
On some low temp scrolls can only do 30.
Yeah. So basically, you'll see when usually it's hooked up to an IDCM module, which usually looks like this guy right here, and there's pretty lights on the front there that will essentially tell you if it's loaded or unloaded. When that happens, the little yellow light will come on telling you that you're unloaded, and then that solenoid will energize in that. And so when that happens, it allows the discharge gas that's built up on top of there to relieve and go into the suction. And so this is essentially what will happen. You're pressing, and then all of a sudden this will energize, and it'll let that discharge pressure up or out through the suction, and then the scroll sets will essentially separate from each other. And so not every single compressor, not every single capacity compressor has the availability to load and unload, but a lot of them do.
Yeah, no, I'm a big fan of the compressors with the internal. There's less of a chance for leaks. So I'm a big fan of those. I will say this though, if you're ordering a digital and it has the external solenoid, make sure you order it in the coil and the relay, the coil and the valve, because sometimes it comes, sometimes it doesn't. And make sure you order the tube for it too.
Tube.
It comes with that pre-bent tube. So sometimes it's there, sometimes it's not. Don't try to bend yours out of copper.
Why not? What'll happen?
It won't be right. It'll crack.
Yay. So I have a question for you, and I coincidentally enough, because I was emailing Copeland this morning for some information, and I was trying to figure out what is the recommendation for how often it should go down to fully unloaded? So basically the 30% or 10%. And I haven't gotten an answer yet, unless you know something. I don't.
Run them hard.
No, because that's what they usually fail.
No, they fail because of floodback.
They also fail because they run unloaded all of the time.
I don't think so. I think they fail. I think they more so fail from floodback, or they fail when the unloader solenoid sticks.
Which would be the same freaking thing if it stays unloaded the whole freaking time.
If it's unloaded the whole time, that's different than cycling. It's still getting some action from that suction.
So I think all right, so hear me out. If the unit stays unloaded all the time, okay?
Not all the time, but like at 10%, like it still gets
10%
4 seconds.
all the time.
4 seconds of sucking.
I know, but if you have a real long run, let's just say you have a run that's 250 long, big old, I don't know, 2 5/8 line, and the compressor is basically well oversized for that. It's going to take a long time for all that mass flow and all that coldness to come back from the freaking coil, and then you're going to overheat the crap out of it. No.
Overheating kills more compressors than anything.
I know.
But that's not unloading.
If it has to unload, where it's not bringing back that velocity back, it's going to take a long time for that pipe to get really cold and go all the way back to that compressor. No?
Yeah, but it's not a single system. It's a rack.
Yeah, but if the one compressor is the only one that's on there that's running because there's no freaking load.
Well, why don't we start doing something about these engineers then? Who designs a rack where only one compressor runs?
I hate you.
I'm just saying.
Yeah, so am I.
Who just designs a rack with only one compressor that runs? Yeah, my screens all went off.
That's weird.
There they go. Yeah, so digital. I will say this with the Copeland IDCM, I've seen them murder more Copeland multiflex boards than anything I've out there. Well, it's not so much the IDCM's fault as it's the person who's changing them, and they go to wire them, and they reverse the polarity on the 24 volts. It puts 24 volts DC or AC on the C1, C2 terminals that are so you see there the C1 common terminal. That common
for the signal right here, right?
Yep, and that common and the 24 volts AC common is fused together on the board. It's soldered together. What happens is if you flip the AC power in the common, if you flip that polarity of the transformer feeding this, it puts 24 volts AC onto C1.
Oh,
which you're putting 5 volts DC out on C2 and 5 volts versus 24 volts AC DC makes smoky. Makes the point burn out on the 4AO. Almost every single protocol I see with Aldi, huge issue at Aldi.
Really?
And like people will change an IDCM and they burn the point out. Somebody can't figure it out. They take the alarm out and they leave the compressor dead. Off. I don't know how many stores.
Wire for wire. How do you do that?
Because they flip the blue and yellow around because nobody thinks about it because it's a transformer and it's 24 volts.
Oh, it's just 24 volts, right?
Yeah. So what I do to solve this, because what Hussman ends up doing a lot of times, they end up center tapping the multiflex board, which makes it worse.
How about you take a picture?
Yeah, but they center tap the multiflex board, which makes it worse because it puts 12 volts on C2.
Oh.
So then you have another problem.
Not good.
So they burn out randomly. So I rewire the protocols so they are not center tapped anymore, and I power them off the same transformer. So there's less of an issue of it causing the short. So if you're burning out AO points on protocols,
yeah,
it's the wiring on you're more than likely center tapped on the multiflex board. You could center tap a multiflex board, but it's an issue with the IDCM not being on the same transformer. It ends up causing them to blow randomly. And it's a very expensive board.
Yeah, it is. So we've talked about these before. And so you cannot put anything less than 1.4 volts going out to these. Otherwise, they won't turn on and it'll say lost the signal. The other thing it won't do it won't actually turn on the contactor coil because the control voltage does go through here. Okay. But this internal relay that's on here won't close unless you have the proper voltage. It won't turn on. There is a process that we can do. Let's talk about the signal a little bit, and then we'll talk about testing this thing out. So right here, you have, as you can see, 10% is basically at 10% is at 1.4 volts. And you can see this linear line right here that goes all the way up. So at 3, we're at 50%. 5, we're all the way at 100%. And then that's when it's going to do the whole pulse width magic where it's the pulsey on and pulsey off. And then on some of the, so this is the scroll. And then if you have a 40 or something, that signal to percentage is going to be off. So I think it goes up from 60% up to 100%. Is that right, Kev?
Yes, I believe so.
Okay. Like I said, you need that voltage, one, because you'll get an alarm that's loss of signal. And usually when that happens, you have to get that signal, to get that alarm to clear, you have to drop the 24 volts, which I still don't understand.
No, you don't.
What?
No, it'll come back. After a time delay, it'll come back.
Okay, because usually...
Yeah, so it has to be above 1 point, or I think it's 1.5 volts
1.44.
DC. Yeah, 1.4. It has to be above that. Usually it's about 1.5. And it has to be, I think it goes through that 2-minute anti-short cycle delay or 2 or 3 minute anti-short cycle delay. It has to stay up there. What ends up happening, though, is a lot of EMS systems end up locking it off, like Danfoss, because they see an inverter proof and they end up locking it off and it won't restart. Right. So that's where it becomes an issue.
And so you can use these for the vapor injection as well. Or, I'm sorry, liquid injection as well. Because usually there's a discharge temperature sensor that gets hooked up to this thing here.
So if you have, you're not going to have the vapor inject or the temp sensor for the liquid injection on the, the Core Sense module or the old demand cooling modules. If you have an IDCM, your sensor is going to go to the IDCM. So it's going to be controlling that liquid injection or vapor injection. Now, very important. So these contacts on here are triacs. They are not relays. They cannot take a short whatsoever. One little arc, whether it be a strand of wire, a tiny short, the point's done. So if you are burning out points, then you have a short somewhere, generally in a protocol or something else. But if you look on here...
Why are you picking on the protocol today?
Because the protocols receive the most digital scrolls.
I know, I'm just joking.
So on this, you have your L1 and L2. That's going to be your control voltage. You got M1 and M2. That's going to be your contactor coil. You got U1 and U2. That's going to be your unloader. And V1 and V2 are going to be your vapor injection solenoid. Now, on this, you have C1 and C2, which is going to be your 5 volts inlet. Now, if you're in a pinch and you come to a time where, say, the AO board burns out and you need to get this compressor to run. So what you do is you add a relay to the CPC or Danfoss, and you wire from C2 to P3 through a relay, normally closed, and that'll give you 5 volts and make this compressor run 100%.
Oh, no shit.
So that's your 5 volts. That's your 5 volts, and then you're going to jump C2 to P1, and that's going to give you a constant 5 volts. And then you could cycle the relay and turn the compressor off, and it still shuts off on your safeties, and it'll still cycle off the rack, but you have to add a point to do this. But that'll get you out of a shit sandwich situation of, say, you only have 2 compressors in that group or 1 compressor, and you burn the AO point out and you're up the creek. Now you could cycle that 5 volts and get the IDCM to work and still have the control of it, but not the full control. You're not going to get the unloading, but it'll still get that. I don't know what Brad's building, but
I'm working on it. Just give me a second.
What are you building? Are you trying to rip it apart?
I am trying to rip it apart.
It's a bitch.
I was just figuring that out.
Yeah, it's like molded to shit on there.
There's 4 screws, and the 2 screws are underneath a sticker that I was like, I don't want to take apart the sticker because I actually don't know if this one is good or bad, and I don't want to break it if it is good. So I'm trying to be ginger with it. Ouch. Oh, there we go. That wasn't too bad. Ooh, there's tracks. All right, so let me just stop sharing for ein Moment, por favor. So you can see right there at the bottom, there's your 3 tracks right there. 1, 2, 3. That are actually doing the on and offy of that stuff right there.
Triacs can cycle rapidly. They just cannot take
amperage.
Any shorts, any amperage, shorts, nothing. They're for pilot duty only.
Yep. Duty. So that's the one that's going to do the solenoid, the unloader solenoid, as well as the contactor coil. So a lot of times if you do have a contactor coil, God help you. Wait a minute, though. Wait a minute. There is a relay on here, but I don't know what that relay controls.
I think it's vapor injection. Or the alarm.
Oh, shit, you are right. Because I'm following the... So you can make out the traces on the... You can see the brown traces on the duty cycle board. But you can see the brown traces that actually go over there, that follow over. And yeah, you're right. That actually goes directly to that other relay. So, no good operator. You'd also see if you have a single phase compressor, there's only one actual sensor that's actually sensing the current right in the middle. So if you look at this right here, on the cover, that C is the common, or the T1. So it's only actually measuring any kind of current coming from that center one. It's not actually measuring any current from the other 2.
Yeah, you have to be on the center one, and or else it doesn't work. And sometimes you have to wrap it a few times.
I've had to wrap it once or twice.
God, Jesus Christ!
I was talking about the wire.
You're fucking
whose brain and gutter? What? Jesus. Anyway, unbelievable. So a lot of alarms, you do have to reset these things by pulling the power. So have you ever? So a question. So you know how like you can sometimes do like a VFD reset. Have you ever tried to kill the power?
Yes. 24 volts.
I didn't even let it get out, but God, no, explain how you do it.
Yeah, you wire the 24 volts through a relay. Yeah. You wire the 24 volts through a relay. You break the hot of the 24 volts, cycle it through a relay. It works good.
That's it. I don't know, man. I think that should be something that's done a lot more than what it is. I don't think I've ever, from the factory, I don't think I've ever seen that be done. You?
No. But I've done it plenty of times.
No, I know. I'm sure you have. I'm just saying, like, why? I don't understand why.
Today's episode is sponsored by the RefRuShield RDP Series differential pressure monitors from Westermeyer Industries, now available for transcritical CO2 systems in addition to other common pressures and refrigerants. When the filter element of your coalescing oil separator is contaminated, it can hurt your system's performance and efficiency. But how do you know when it's time to replace that filter? Wait too long to replace, and you could end up with a nasty filter blowout. But replacing too often can be a waste of time and money. The answer is installing a differential pressure monitor. The RDP Series differential pressure monitors, including the new transcritical CO2 model, are available now from Westermeyer Industries. To find out more information, email sales@westermeyerin.com. That's WESTERMEYERIN.com.
Because a lot of times, like I've seen where usually sometimes the customer will have you go through and be like, I want you to set up all the time delays on the low pressure switch or whatever. And then a lot of times someone will put, if this is the first compressor, they'll put it for 30 seconds or whatever. If it's on the master low pressure switch. And then all of a sudden it ends up doing loss of signal because you don't have the voltage going to it. And then all of a sudden it doesn't want to turn back on.
Correct. And that anti-short cycle delay kind of hoses you down for that. But yeah, I mean, digital scrolls are fairly reliable. They just do not handle liquid slugging very well. They end up wearing the bearings out, and they wear them out faster, and then they end up smoking. And then the unloader solenoid welds in because it shorts and the triac stays on, and then it just runs itself to death, unloaded. And then it smokes like Brett said, but it was going to die anyway.
Yeah, like I said, I don't know if I'd have to cut open every single freaking compressor that we've ever diagnosed. But you are right. A lot of times, usually it is liquid. But I'm just curious, like how much unloading it can handle before it's like, yeah, you know what? I've given up the ghost. But I don't know that. I don't know that answer. I just didn't know if you ever heard that before. So you want to start talking about the 40s, and I'm going to look for something really quick.
40 on digital's not my favorite.
Really?
This is not my favorite. You don't get the unloading capacity you do with a scroll or you do with a 3D. If I'm choosing a digital on a rack, it's definitely a 3D.
You want to explain the load, like what the percentages are and unloading?
Yeah, it's so on a 40, you can only go to 50%. Okay, so you have 0 to 50% because you're only unloading one head. So you only have that capacity range of 50%.
Is
So
it
you
50
can go,
or 60?
no, it's 50.
Is it? Okay. I didn't know if they could fully just.
It shuts off one head completely. So on a 3D, you can go down to 10% like a scroll. So it is able to modulate because it's shutting off that complete flow of that compressor on, off, on, off, on, off. A 3D is always going to be my choice because you get so much better modulation out of a 3D. So that's going to be my pick with them. A 40, if you're in a pinch and that's all you can do, it's better than nothing. But I would rather retrofit to a 3D compressor with the same capacity than doing a digital unloading head on a 40 because you're not going to get the same results out of it as you are on a 40 or a 3D. I'm sorry.
Speaking of a 3D, someone asked me to ask you about unloading a 3D and how much percentage you get out of it.
I believe it's 10%.
Is it? Okay. Someone asked me to ask you. They said, yeah, they had a good conversation with you about it.
I'm always going to choose a 3D for that. Just it functions so much better. I've done a bunch of these. Like I think maybe 6-7 years ago, I did 14 of them at different stores, and it cut the energy usage on the racks like tenfold. Like everything calmed down, no more cycling. Went from 200 cycles a day down to 10 cycles. Everything looked beautiful. The compressors weren't short cycling. Oil was better. That short cycling and everything else kills compressors. And digitals are a great thing for that. Personally, I'll take a VFD now over anything. VFD controls is so much smoother, but a digital is on an existing rack is the way to go.
Gotcha. So that temperature sensor. So I just want to show you guys this real quick. Here we go. So it's basically a 90K thermistor, right? So you can tell that because it's 77 degrees, 90,000 ohms. So basically the same temperature sensor that's working. I'm pretty sure it's the same one that runs the demand cooling module, is it not?
Yes.
So it's basically the same temperature pressure, or I'm sorry, temperature resistance as the other one. So you can see if the head's all the way up to 109, it's 42,543, all the way down to 59 degrees. It goes down to, 141,426. I wonder if they actually have a BAPI chart for that.
I'm sure they do, because I'm sure BAPI makes it.
Probably. And then let's see, bench test of sensor, blah, blah. No, it's not. That's using the ohm meter capable of 1% accuracy, whatever. Oh, that's just checking that for that. Okay. No, there's a methodology on how to do the, whatchamacallit, how to jump these out to test all the outputs. Because like sometimes on those tracks, sometimes they won't fully like engage because there's something actually wrong with that track. Have you ever seen that? Where then the amperage on the compressor goes, or I'm sorry, amperage on the control circuit goes crazy because it's like partially closing, not all the way closing. Have you seen that before?
Yes.
And so I'm looking for that procedure and I can't find it right now. Hold on. What's that?
I don't know. I said a brain fart.
I'm looking for the procedure.
For what?
For how to go through where it actually, you can run through every single one of these outputs.
Really?
And yeah.
No shit.
Yeah, you have to put a jumper from one to another. I think it's probably the same.
I just condemned the board.
I think it's actually the same procedure that you were talking about, because you have to take two jumpers and you basically jump one wire to like P1 or C1 or something like that. I think
I'm just condemning the board. I have so many of them in my van that like people have condemned that aren't bad.
Nope, I don't have it. Damn it. Can't find it right now.
If you need to make it run and you think it's a signal issue, you jump P1 to and C1 and P2 to C2, and then that'll give you your 5 volts.
I'm pretty sure that's actually a procedure. Like I'm like 99% positive.
That'll give you your 5 volts to run. But most of the time, it's if you have a safety line issue, it's kind of like microthermal. Like it knows that it's missing that leg of power on there, so it knows that it's missing. So it throws that safety line alarm saying, "Hey, I have an open line from here to here. What's going on? What safety's tripped? Is it the oil switch that somebody's been resetting for 16 weeks?"
Damn it. And then if you are going to order a new IDCM, make sure you order the right one.
Yes, because the air conditioning one is different. Some of the scroll ones are different. Some of the bigger ones are different.
Yeah, so that's what I was going to show. I thought I had it on here. You can tell which one's which because when you look at the chart, when it does actually show it, I can find it, which I can't right now. But like one will go from, it'll say 10 to 100%, 10 to 100%, and then the other ones will be like 50 to 100 or whatever. And of course, I can't find it right now. So I'm going to hide this for right now. And
I'm going to hide this for night. So also, if we're talking digitals, obviously Bitzer has a digital too. So you have 2 flavors of them. You have the older flavor with the Siemens module, which was their Verispeed, or not their Verispeed. What do they call it? The
Modulode.
Or CRM2 or Modulode compressor. I don't remember. CRM2.
We're gonna say it, and Greg's gonna be like, "You guys did it wrong."
Yeah, I forget. It's CRMCs.
So it is.
No, that's a new one. All these damn acronyms. So the older Bitzers had the Siemens module in there, and it gave a 0 to 10 volt signal, and it would pulse relays on and off. The thing I like about the Bitzers, though, is they will let you shut all 3 heads off on a 3-cylinder compressor. And on a 4-cylinder compressor, they will let you shut both heads off. So you get a little bit more modulation out of that. It works great.
Agreed.
So the Siemens module, not so great. It's not very cycle quickly. Like, honestly, I think you could do a faster job with a 8RO point and a solid state relay, but it's not the best with that.
Wait, which one? The one with the little card.
Yes. Not the best.
Yes. So it's a little laggy. So so that one's a little bit different. So you give it that one, the Siemens one, you have to give a signal. So you give a signal from the suction group, right? If we're talking E3 or E2, you do have to make sure, just like you do have to make sure you have the right IDCM module, you have to make sure you have the right card. There's a card that gets plugged in there, and the earlier modules, they had a plastic card that was in the thing, and a lot of time a little tray. And what would happen is if there was a slight vibration in the rack, it would shake the card out, and then all of a sudden there's a little light on there. It's either glows green or red. Yeah, when that card would like shimmy its way out, it starts glowing red, and then it wouldn't. You'd see your suction graph go to shit, or it was just loading and unloading as far as shutting off other compressors rather than actually having seamless suction pressure. When they do work, they work well. But just like the IDCM, you have to make sure you have the right card for the right compressor that you're putting in there.
Yes, the card is very frustrating, and don't push hard because it goes right through the stop and into the thing. The CMRCs are miles ahead of this thing, though. Like, they are so much better. They're quicker on loading. It's all-in-one better control. That Siemens module, I would never order one with with a CMR, if I had the option to do the CMRCs, which are the new modules.
Oh, so real quick here, look at this. This is a new thing, unless you're aware of this. I've never seen the 15-second cycle time. I've only ever seen the 20s.
I've seen 15s. I think the 15s are for the air conditioning.
Oh, really? Yeah, that would kind of make sense. 20 seconds. So we'd have to look up which one. So here, this one. So this one goes from 10 to 100, 10 to 100, 10 to 100, and then 50 to 100. So whatever this one says that this one goes to. Copy text. Oh, right there. So 124.01. Yeah, look at you. Yeah, so the air conditioning ones. Okay, so if you're working like on an Addison or something like that, they only allow it to cycle. The cycle time changes a little bit. Still has the same signal, right? And
Correct.
No capacity limit. Yeah, so you were right. I thought for some reason I thought you could only unload it down to whatever, but at least I guess they changed the spec of it a little bit because then you're allowed to have that one head at least brings something back, right?
Yes. So the one head on a 40 you can't actually unload.
Gotcha.
Because the way the oil ported through there, so you can't unload it. That's why you could only unload the right head. You can never put an unloader on the left head.
Kevin, let me ask you a question. Maybe you know this, and I think I know this. Well, now I'm questioning it. So why is this one 310? Then we have 268, then we have 268 on these ones.
I'm assuming that's for a scroll.
So that's what's throwing me off here because look, it says that a 3D discus can also use this same module. And that's what's throwing me off a little bit. That's originally what I thought. And
That's weird.
yeah, that's what I'm saying. So they're saying that if that 3D gets up to 268, and that would be internal temperature, then that means it would have to be 210.
Yeah, 210, which is nice, but holy shit, have you ever worked with 407F or 40, even 448 gets some spicy discharge temps. So at 310 you may need, to be honest, but at that point you're making compressors cook and not so happy.
No, and I understand that, but because this one, these are the ones that typically go plug right in the head. So I'm wondering how they're figuring in this one right here, because that would essentially go into the head just like the 4D. You know what I mean? That's where I'm throwing off a little bit.
Yeah, I generally pick the module that's in the kit. Like when I'm ordering, there's actually an entire kit you could order with these. If you go through here, it'll give you the part numbers. Generally, they don't want you choosing a compressor like older than 7 or 8 years old. I've done a couple that are older than that and they're still running and they're fine. But I will say this, there was some Delta Reed discus compressors out there, and they're conceiving, they say discus compressor, and it's not actually discus valve plates truly. They're Delta Reeds. So it's like a hybrid between a reed valve and a discus. You cannot retrofit those to a digital. It'll come up and it'll say in the model number that you can, but if it's a Delta Reed compressor, you cannot. The head won't match up.
Delta Reed. Explain.
I don't know. It's like a hybrid pre-discus.
Mm-hmm.
Like in between the discus and like a Delta Reed, like hermetic.
Okay.
Or Delta, or like a normal reed valve compressor.
Okay.
It doesn't have a discus packs.
Okay. Fair enough.
So it was something they must have done for a little bit, and they instantly switched to discus. Now, a moduload compressor is not a digital. Not the best option. Moduloads were a good option before they had the digital. But if you're going to have to choose a moduload or a digital, I'm going to choose a digital every day, any day over. Moduloads, their unloading is different based on the head pressure. So a moduload compressor is a 3D with an unloader on top of it that does not have the unloader IDCM or anything like that. It just has a unloader controlled off of the suction group or something else. It is not able to modulate like that. And what ends up happening is as your head pressure decreases, the amount of unloading you have decreases because the way it shifts the pistons and the heads to block everything off. So as your head pressure decreases, your unloading capacity decreases, which is not ideal because generally when it's cooler out in the wintertime, you need more unloading than you would in the summertime. So in the summertime, the compressor is way more efficient in unloading.
Okay, so is it this guy right here?
Is it a yes? Those things suck to rebuild.
Hell yeah.
So there's a bunch of O-rings in there, and if they tear,
They go
or
on
something
top of
happen. Yep. And then if a customer tells you to, hey, this compressor's having trouble when it's unloading, and to blank off the unloader because this has come up because they don't want to use it and blank it off. There is blank off plates, and there is unloader coil plates or gaskets. They both fit over the unloader or the blank off cover. If you install the unloader gasket on the blank off cover, you will have nonstop nuisance random oil trips. If you don't order the shipping blank off gaskets.
I think I know what you're talking about. There's one that has like a small little line in it, and then there's another one.
Yes. So we did this like 8 years ago. And me and one other guy were back on this compressor like 7 times for tripping on oil. It ended up being that somebody had removed the unloader and they put the wrong gasket underneath the blank off plate.
Yeah, I've seen that. Not a good time. Trying to look for that damn gasket, but there it is. Is this the one you are speaking of?
Yes. Yes, it is.
That's not the That's not the shipping one, though, right?
I believe it actually is.
What's the one? No, the shipping one. I thought it had one line going across.
No, that's the unloader gasket up there. Go back up. That's the unloader gasket. See how it's got the holes in the groove? That doesn't have the holes in the groove.
That's right.
Yes.
That's right here.
That is the unloader gasket. The upper one is the shipping gasket.
That's the wrong one.
Yes. Bad time one. Bad time.
Yeah, I've seen where they. I've seen because usually you can tell. So on the heads of these compressors, you'll see a little identifying tab right here. That in the forging of the head, you'll see a little triangle that's not anywhere else. That identifying tab on the gasket has to go with the identifying tab on the head. If you don't put that there, it does not work. And then if it's like that for
it's wrong.
It'll fit either way. I've seen it.
I know, but if it doesn't fit with the tab on the tab, then it's wrong.
But the gasket still fits, man.
Yeah. And then compressor go trippy.
It does. It doesn't like it at all. So I want to get Greg on here. I saw Greg this week. He had a broken wing.
Ooh.
He was all slinged up. I guess he had some old man rotator cuff issues.
Typical refrigeration guy issues.
Yeah, usually knees, back, shoulders,
rotator cuffs.
Everything.
That's a fit fitter thing.
Yeah.
Well, let's call it for this, and I got to go book a flight to Texas.
Have fun with that VFD.
Yeah, oh my God, it'd be so funny if I walked in there in 10 minutes and fixed it. And I would love to never hear the end of it.
We'll have material for a month. All right. We'll talk to you guys later. Bye.